up on science.
Okay, I think you are warm, so I'm going to introduce to the stage our very first presenter, PhD student from Mount Stromlo at the Research School of Astronomy and Astrophysics, the wonderful Ryan Ridden-Harper.
My job is to make you all want to forget the talk and buy drinks. So just keep that in mind. Okay. Whoa, what's that? Is it a balloon? Is it a bird? Is it a plane? Oh, perhaps it's a loony PhD student's project flying away. Perhaps it's my PhD project, which is building an ultraviolet telescope to put on a balloon and fly away into the atmosphere. So it's rather quite a loony endeavour that we're encountering. Oh, there we go. Yeah. There you go. Ah, good. Thank you. Okay. So I mentioned something called ultraviolet astronomy. So a good thing to do is to define what ultraviolet astronomy is, because you may not have heard of that before. So here is the accepted definition. Ultraviolet astronomy is the study of inherently interesting things. We know it's inherently interesting because the sun doesn't emit much ultraviolet radiation, and the sun is known to be average and mundane. Thus, anything the sun isn't must be interesting. And I think we can all agree that is quite a nice definition. The only problem with it is it also agrees that radio astronomy is interesting. And we all know radio astronomy is just witchcraft dressed up as science. So now that we've got ultraviolet astronomy understood, let's start thinking about the thing we always have to talk about, the Great Ozone War. So above the Earth, there's this thing called the ozone layer, which sits up there and protects, I should use air quotes there, from ultraviolet radiation. So it would otherwise hurt our cells and we'd die quite miserably. But there's a problem, because ultraviolet radiation is the thing I want to study, but that thing there eats all of it. So, yeah, exactly, good. You're catching on. So we'll all agree that it would be better if the ozone layer disappeared. Yeah? Yeah. So the world community agreed to this in the last century, and they came up with an idea of releasing things called CFCs into the atmosphere. And we began the Great Ozone War. Where is the button? There it is. And we came to a bit of a problem. We started realizing we can't win this without killing ourselves. So they had to reach kind of a compromise. Some say we lost the war, but I don't know. It's called the Montreal Protocol. It stopped this age war that would have killed us all, and so it left us UV astronomers with this everlasting problem of, if we want to do ultraviolet astronomy, we need to get above the ozone layer. So one thing we can do is put telescopes in space. And those... Yeah, there we go. Ultraviolet... I don't even know anymore. So if we put telescopes in space, the ozone layer is not a problem. But you'll notice that there are only 2 telescopes up here on the PowerPoint. That's pretty much all of our ultraviolet telescopes. And the unfortunate thing is, both of those aren't really doing ultraviolet astronomy all the time. And the Hubble telescope's gonna die soon. So yeah, that's sad. That's real bad. So what we can do is either send a new mission into space or do something cooler. We can take a small telescope and ignore the space because it's far too expensive and difficult to do. And we get a small telescope and we strap some balloons to it, and then we send it off into the atmosphere. And if we fly it above the ozone layer, we'll discover something quite cool. And I actually have a treat for you all, a real live prototype. Here it is. So here is the culmination of my PhD project. It will be launching in the very near future. Oh, don't take pictures of this, it's still confidential. What we're going to do with it, that's a good question. So what we're going to do is launch this up in the atmosphere, and I'll show you what it's going to do. So this is a very high-tech simulation. There we go. So this thing will launch from the ground. It'll go up above the ozone layer and float around for many months at a time, doing what we call a survey of the sky, looking for ultraviolet things that might be doing their business up there. And then it will eventually finish its job, come back down, we'll recover it, and be ready to launch it once more. So that's the purpose of this thing. You know, it's prototype. So the question becomes, why bother doing this at all? And the answer becomes because it's interesting, as we saw before. So if we take our telescope, work out the kinks of that one, send it up into the atmosphere, what we want to see is very interesting things, explosions that are going off in the night. And these explosions might... Yeah, thanks. It's pretty cool, eh? Yeah, it is. See, it faded away. All right, let's bring it back. Explosions, wow. So there are lots of things in space which explode in very energetic explosions, and they release lots of ultraviolet radiation. And it's kind of a tracer of the very energetic processes that happen in space. So some of the things we want to find are stars just as they blow up, known as supernovae. There are different types of them, but there's one in particular we want to hunt, and it's used for cosmology. Oh, that's a fancy word. Yeah, good. So cosmology is the study of the universe at large, and this one type of supernova is what we use to measure distances in the universe. And we don't quite know everything to know about this supernova. So if we study it with ultraviolet light, we'll work out a better idea of how these things actually explode, how bright they should appear to us. And from that, we can calculate distances much better and perhaps understand something known as dark energy. Ooh. Yes, very exciting. So that's what we're planning to do with this telescope once it gets fixed. But for now, that is all I have to tell you. Thanks for listening.